Welcome back. As promised on the previous section, we will continue now with limit and reactant, theoretical yield, and percent yield, but we're going to do it with the mass now instead of the moles. So before we do anything further here, go ahead and do that daily work. You should be able to do this daily work with what you already know. So you should be able to find the limit and reactant given the mass. So let's work on this problem. And the goal is to find the theoretical yield. Remember, theoretical yield is once you find the limit and reactant, calculate the product, and that's in theory what you're supposed to produce if all the limit and reactant reacts. In reality, when you go to the lab, you have problems sometimes, and that doesn't happen. But in paper, if you know which one is the limit and reactant and you assume that 100% of it is going to be converted into the product, then that's what we call the theoretical yield of the product. So, on a problem like this, determine the theoretical yield of silver chloride. So we're only looking for silver chloride. When these two quantities are allowed to react. We are given mass, so the first thing we have to do is to find the moles. So we're going to take the 1.5 grams of silver nitrate. We're going to change it to moles because 1 mole of silver nitrate equals 168.87 grams. And these are going to be moles of silver nitrate. But we're not looking for the moles of silver nitrate, we're actually looking for the moles of silver chloride in relation to the moles of silver nitrate. And this is what we call the mole to mole ratio from the balance equation. So on this case, we have 2 of silver chloride for every 2 of silver nitrate. That allow us to cancel the moles of silver nitrate, allowing us to find the moles of silver chloride. We're only trying to determine the theoretical yield. Well, let's do it with mass. So we want the grams of silver chloride, not the moles of silver chloride. And the mass of silver chloride is, give me a second to find it real quick. The mass of silver chloride is going to be 143.3. 143.3 grams, which tell us that our theoretical yield, since we are assuming that the 1.5 grams of silver nitrate is reacting 100%, in theory, we should get then, let's do this, 1.5 grams multiplied by 1, multiplied by 2, multiplied by 143.3, divided by 168.87, divided by 2, divided by 1, and that's going to be 1.27 grams. So, if the silver nitrate was the limiting reactant, then we will produce 127 grams of silver chloride. But we don't know which one is the limiting reactant yet. So we have to do the same thing with the magnesium chloride. So if we have 1.5 grams of magnesium chloride, we will change those to moles of magnesium chloride, which is 1 mole for every 95.2 grams. And then we will get rid of the moles of magnesium chloride because we want the moles of silver chloride. And according to the balance equation, you have 1 mole of magnesium chloride for every 2 moles of silver chloride. But we don't want the moles of silver chloride, we want the grams of silver chloride. And we know that 1 mole of silver chloride equals 143.3 grams. So this gives us the grams of silver chloride that will be produced, in theory, if magnesium chloride was the limiting reactant. So let's find out. So 1.5 grams multiplied by 1, multiplied by 2, multiplied by 143.3, divided by 95.2, divided by 1, divided by 1. And that's going to be 4.52. So now we can compare. If silver nitrate was the limiting reactant, we can produce 1.27. If magnesium chloride was the limiting reactant, we can produce 4.52. Obviously, the least amount is 1.27, so the silver nitrate would be our limiting reactant because it's the one that produces the least amount, which means we will never be able to produce 452 because by the time you want to use all the magnesium chloride, the silver nitrate that you need is going to be already gone. It's like having 1 egg and 100 package of flour. It doesn't matter what, you're only going to be able to do whatever you can do with 1 egg to make the cookies. All the other flour is wasted. So the limiting reactant on this case is silver nitrate, which is the one that produces the lower amount. And we're talking about the amount of product that you are going to produce, so that means you just found the theoretical yield. So the theoretical yield is the amount of product that can be produced by using the limiting reactant. So we can only use the limiting reactant. So let's do that again once more with the second problem. So on the second problem, we're going to take 3.5 grams of silver nitrate. We're going to change that to moles of silver nitrate. Then we're going to change that to moles of silver chloride. And then we're going to change that to grams of silver chloride. That means that we don't want the grams of silver nitrate. We don't want the moles of silver nitrate either, which means we don't want the moles of silver chloride either because we want to get the grams of silver chloride. So for every 1 mole of silver nitrate, you have 168.87 grams. For every 1 mole of silver chloride, you got 2 moles of silver nitrate. And for every 1 mole of silver chloride, you have, what did we say was that? 143, just give me a second to find that again. 143.3 grams. So when we do all that, we have 3.5 times 143.3 divided by 168.87 divided by 2 divided by 1, which is going to be 1.49 grams of silver chloride. So that would be if the silver nitrate is the limited reactant. So let's check the silver chloride. 2.5 grams of silver chloride. We don't want the grams of magnesium chloride, sorry, because we want the moles, and that's going to be 95.2 grams. But we don't want the moles of magnesium chloride. Because we want the moles of silver chloride. And there's 2 moles of silver chloride for every 1 mole of magnesium chloride, which I just noticed I made a mistake on the first one. Silver chloride should be 2, not 1 like I did there. So let me fix that. So let me fix the top one again. There was a mistake on my mole to mole ratio. So 3.5 times 2 times 143.3 divided by 168.87 divided by 2 divided by 1 give us instead 2.97 grams of silver chloride. And then as we continue with the next one, I do not want the moles of silver chloride because I really want the grams of silver chloride. So 1 mole of silver chloride equals 143.3 grams, which tells us that we are going to have 2.5 times 2 times 143.3 divided by 95.2 divided by 1, which equals, just a second, 7.53 grams of silver chloride. So obviously the 2.97 is the smallest one. So magnesium nitrate is the limiting reactant, and the theoretical yield is going to be 2.97. So once more, if you're given a problem where the amount of both of the reactants are given, you need to find out which one is the limiting reactant first. You can do that by using the mole to mole ratio and finding how much of the product you can make. If you do it that way, you're finding the limiting reactant at the same time that you're finding the theoretical yield, because the theoretical yield is always going to be the one that goes with the limiting reactant. So with that said, you should be able to do this daily work. Actually, let's go ahead and do only 2 of them. I think you already have enough practice. So only do the first 2, A and B only. So let's do something else now. So on this problem, we are given the theoretical yield. So this is the theoretical yield. And we are given the actual yield. And the question is, what is the percent yield? It's an easy problem. Percent yield is nothing more than the actual yield divided by the theoretical yield. And then multiply by 100. So the percent yield for this particular reaction is going to be 18.5 grams divided by 28.8 grams multiplied by 100. If you have moles, you don't need to change it to grams. You can do it with moles to moles also, or grams to grams. So 18.5 divided by 24.8 times 100 equals 74.6%. Notice that the units do cancel. So once more, let's make sure we understand this. If you were making cookies and your recipe said that you should be able to make 10 cookies, but when you put it on the oven, you go take a break, one of your kids, without you noticing, ate 2 cookies and you never find about it. When you open the oven, you only have 8 cookies. You were supposed to make 10 cookies, but your product, independently of what happened, your final product was only 8. So you have 8, which is the actual, divided by how much you were supposed to make, which is 10. So you have about 80% yield on the cookie adventure you took. So the percent yield is a simple concept. It depends on knowing how much you actually collected at the end. So you have to be looking for those keywords on the problem: produced, collected, isolated, something like that. And with the stoichiometry, all the calculations you've been doing, find the limit and reactant and see how much you should be able to make in theory. That's your theoretical yield. So once you have your theoretical yield and your actual yield, it's just a matter of using the formula. So let's do another problem related to that. Let's say that we have this reaction going on. Calcium oxide reacting with carbon dioxide to produce calcium carbonate. And we're saying that the chemist is using 14.4 grams of calcium oxide and combining that with 13.8 grams of carbon dioxide. One of those two is going to be the limiting reactant. We don't know which one yet. So what we're going to do, we're going to take each one of them like we did earlier, and we're going to see which one gives us the lower amount of product. And that's going to be our theoretical yield. And then the problem also tells us that when the reaction is finished, the chemist collects, that's the key word, collects 19.4 of the calcium carbonate. So this keyword collects, is telling us that this is our actual yield. That's what the reaction produced in reality. So we're supposed to find the theoretical yield, which we're gonna do by seeing how much product the calcium oxide produces, and by seeing how much product the carbon dioxide produces, and whichever gives us the least amount, that's the limiting reactant, and that's our theoretical yield. So let's do that. So if we have 14.54 grams of calcium oxide, how many grams of the products, calcium carbonate, we can make? If we have 13.8 grams of carbon dioxide, how many grams of calcium carbonate we can make? Whichever gives us the least amount, that's our theoretical yield. So let's set it up with the train track. We want the most of, always grams to moles. You cannot do anything unless you have the moles. 1 mole of calcium oxide equals 56.1 grams. But we do not want the moles of calcium oxide because we're actually looking for the moles of calcium carbonate. And according to the balance equation, is 1 to 1. But we do not want the moles of calcium carbonate because we actually want the grams of calcium carbonate. And the molar mass of calcium carbonate is going to be, just a second, that's going to be 100.1. It's going to be 100.1 grams for every 1 mole. And that's going to give us, let's see how much we get out of that. So that's going to be 14.4 multiplied by 1, multiplied by 1, multiplied by 100.1, divided by 56.1, divided by 1, divided by 1. That's going to be 25.7 grams. So that's a possible theoretical yield, but we don't know if that's going to be the limiting one. So let's do the one with calcium dioxide also. So we want the moles of carbon dioxide, which is 44.0 grams per mole. But we do not want the moles of carbon dioxide because we're looking for the moles of calcium carbonate. But we do not want the moles of calcium carbonate because we actually want the grams of calcium carbonate. So one, according to the reaction, is 1 to 1 for the mole ratio, and 1 mole of calcium carbonate is the same as 100.1 grams. So when we do that calculation, we're going to come up with, let's see how much we get. 13.8 times 1 times 1 times 100.1 divided by 44 divided by 1 divided by 1, 31.4. So the least amount is produced by the calcium oxide. So calcium oxide is our limiting reactant. The theoretical yield is the product, the amount of product produced by the limiting reactant. So we don't have to use this one at all. So our theoretical yield is 25.7. Our actual yield is 19.4. So 19.4 grams, which is the actual yield, divided by the theoretical yield, which is 25.7, multiplied by 100, is going to give us how much? 19.4 divided by 25.7 is going to equal 75.5%. So on this reaction, we were only able to produce 3/4 of what we were supposed to produce. So reactions are never, it's rarely that you have a reaction that gives you 100% yield. I will be suspicious about that because in the lab, you have to use glassware, and sometimes your products get stuck on the glassware, and you cannot count that when you weigh the final product. So that's how we find the limiting reactant, the theoretical yield, and the percent yield on this particular problem. So now you can work on this problem, and when you are done with this problem, work on that one because you need practice on this. And once you do that, we are done with these objectives. So using mass, beginning with mass, now you know how to find the limiting reactant, the theoretical yield, and the percent yield. And make sure you understand what they mean, not just a mathematical calculation. So that's the end of this section of the chapter. We have one more section to go where we're going to be relating the mole-to-mole ratio to the energy produced on the reaction. So when we come back, we're going to continue using stoichiometry, which is basically calculating using the coefficients of a balance equation, but we're going to use it with energy also, and that will be the end of the chapter. So see you soon. Take care.